Let us solve the question number 18 in the question bank of DBMS. The 18th question is as follows. Given below are the two sets of functional dependencies for the relationship A, B, C, D, E, and they have asked are they equivalent? So the two relationship that they have given here is A derives B, AB derives C, D derives AC, and D derives E. This is one set of relationship that they have given. And they have given the second set of relationship, that is A derives BC and D derives AC. Now they want us to know whether these two relationships are the same. In other words, given the two functional dependencies for this relationship, we have to imply that both of them are going to give the same set. So in other words, closure of this set and the closure of this set are equivalent. So how do we prove that thing? The way in which we prove that thing is we will say that using these relationship we can derive this set. That is one way. This is one way. So using the first relation set of a relationship, we can get the second set of relationship. In the same way, in the second side, we will say that using these two relationship, we will be able to derive all these relationship which are given over here. So it is possible for us to using this, we will be able to derive these relationship. So that means to say using one, we can derive the second, and using the second, we can derive the first one. In other words, we say that both of them are equivalent. So let's go ahead and let's solve the problem. And the first thing that you will ever do with this kind of problem is you first write down the functional dependencies. That's very much required. Whenever you get to this kind of questions, you first write the functional dependencies. So this is one set that is given. This is second set that is given. We will go for the easiest one. What is the easiest one? We will try to derive these, the second set using the first set. So in other words, we would like to find whether A derives BC, whether that can be derived using these relationship. So using these, is it possible to for us to conclude that A derives BC? Remember, A derived BC is in the second set. So we try to prove whether this functional dependency is there or it can be derived by using the functional dependencies that is given in the first set. So let's start with the first one. So how do we prove that thing? So we start with the first one. So we know that A derives B. This is given over here. And it is also given that AB derives C. So you know very well. So A derives B. Okay? So let's say A derives B. And you notice that AB derives C. So using A, I can get B. So using A, I will be able to get B. So naturally, I will take this A, and I know using A, I can get B. So that is for sure. Okay, and now I take AB, and then I derive C. So I take AB, and I derive C. So using AB, I can derive C. So what is the conclusion that you can say? So what is given over here is using A, you can get B. And using AB, you can directly get B. Using AB, you can get C. So that means to say that this B, even if you are not giving me, yes, it is possible for us to get C directly using A, because I know that if A is given, suppose in here, if B is not given here, then also I will be able to get C. How it is possible? Yeah, I know that using A, if you look at this first relationship, using A, I can get B. So I take this B, using A, I first get B, and I put that B here. Okay, I put that B here. Now what I have is AB. So using AB, I can get C. So this is called as pseudo-transitivity. So using pseudo-transitivity, we can say my tongue is twisting. Okay, so I can derive and say that A can derive C. So this is that. Now, what is so great about it? Now let's start with the first one. A can derive B, okay, and we have proved that A can also derive C. Then we can very well say that A can derive BC. So A can derive B, A can derive C. Directly I can say A can derive B and C together. Okay, done. So in other words, I have proved that this relationship A derives BC can be obtained by combining these two relationships. So the first part is over. So let's see whether this relationship can be derived using the set which is available here. So let's start with that thing. So what is given over here? So let's start with this one. D derives AC. So given there, and it is also given that D derives E. So what you can say, D derives AC, D derives E. So I can combine them and say that D derives ACE. Now you know very well D can derive ACE. That means D can derive C. Okay, D can derive E as well as D can derive A. So D can derive all of them. D can derive A, C, E. In other words, you can take any combination of them and you can say D can derive A and E. So because D can derive all the three, you can definitely say that D can derive any combination of any of these two. So any of these two, in our case, the special combination is A and E, that is given over here. So what is given here, don't get confused. So what is given over here is D can derive ACE. So what is given over here is D can derive ACE. So individually, D can derive A, D can derive C, as well as D can derive E. So D can derive, or any combination of them. So D can derive also AC, D can derive CE, D can derive uh, which one AC. D can derive any one of them because D alone is the only one attribute that derives the other one. So you can say that the D derives AE, and that is where here. So what we have proved now is these two relationship can be obtained using the first set of relationship. Now we have to prove the other way around. What is the meaning of that? We have to prove that this A derives B, AB derives C, and A derives AC, and A derives E. All of them can be obtained using the combination of these two. So let's go ahead and let's do that thing. So let's try to find whether A derives B, that is this A derives B, whether this can be obtained using these two. So let's try to do that thing. So how do we go about doing that? Whether A derives BC. So I'm going to take the first one. Let's take this one. A derives BC. So let's take this one. So A derives BC. What does that mean? It means to say that you can decompose this one. Let me write that thing. So A, not this A derives BC. This is given. Remember, let me just show you what is given over here. A derives BC. This is given here. So I'm going to write that thing over here. So I'm going to say, just a minute. Okay, A derives. Okay, A derives. Let me write like this. A derives BC. So I can say that A derives from this. I can say A derives B. How? Because decomposition. You can decompose it and say that A derives C. Okay. So in other words, I have directly proved that using because A can derive a combination of these two, you can directly say that A can derive B as well as A can derive C. And what is required for us is A is derived, I mean B is derived by A, or A can derive B. That is what has to be proved here. So directly I have proved that A can derive B. So let's take the second one. AB can derive C. So this is the second one. Can we derive AB using C? So again, let's take the same story. A can derive BC. So same one. I have taken the first one here. A can derive B. This is a set that is already given. So A can derive BC. So what is given over here is A can derive BC. This is given in the second set. Okay, done. Now, what we can think of doing is now if since A can derive BC, remember when A can derive BC, okay, one thing you will have to notice here is with A, okay, you put any X, any attribute, it is going to derive BC. Now you may say that how is that possible, sir? Remember, X is not required at all. Whatever X you are saying here, this thing is not really required. Why it is not really required? Because A alone can derive this. Okay, A alone can derive BC, whether that X is there or not, whether you put it or not, it's going to derive that. Now I'm not going to put any X here. What I'm going to do is I'm going to play a trick here. I'm going to say A, and instead of X, I'm going to say B. AB derives, okay. So I'm going to say AB derive BC. Remember, you may say that how it is possible. Remember, A alone can derive, see, A alone can derive B and C. So this AB, that whatever I put here, this thing is not really required. This is without this also A can derive BC. But if you put that, it's not going to make any change in the relationship. It's going to derive the same thing. But with this, I'm going to play a trick now. Okay. Now, because you said that AB can derive BC, okay, I can say that now AB can derive C. Okay. So how is it possible? You may say that how it is possible, sir. So let me give you the same story here. Let me start with the blue color. So when I say A derives, if I say A derives, see, you don't have the confusion. If I say A derives BC, you can say by decomposition, you can say that A can derive B. Okay, you have no confusion regarding that. And you can say A can derive C because you can decompose it. Because see, A can derive BC means A can derive BC means A can derive B as well as A can derive AC. Now, what is the story here? Story here is AB. See, let's say this one AB. Instead of A, I'm taking two attributes now. AB derives XY. Let's say I'm just giving you a different one. What does this mean? AB can derive X. Yes, AB can derive Y. Is it not? Same analogy I am using here. The last analogy, where is the color gone? Okay. So the same analogy. So how did I say that? So A can derive, and you say A can derive BC. When you say A can derive BC, you are agreeing that A can alone derive B separately, and A can derive C. Yes. In the same analogy, AB derives XY. AB can derive X separately. AB can derive Y separately. Now, instead of XY, what we have is AB can derive, I'm saying BC. So I can say AB can derive B as well as AB can derive C. So what is required by us is to prove that whether AB is there in the second set. So what we have proved here is, if I go back, is the second relationship here. AB derives BC. This relationship can be obtained using the other. So let's try to see whether D derives AC, whether this is there in that relationship. So let's go with the second one. So let's go with the D derives AC. For this, I'm going to use the remaining two this relationship. So what we have is A derives AE. Let's take this, not A, D derives AE. Let's take this relationship. So D derives AE. What you can say, using this, you can say that using decomposition, you can say that D can derive A as well as D can derive E. Okay. Now let's go back and let's take this relationship. This relation, that is A derives BC. So now we know that when I say D derives AE, D can derive A, D can derive E. So I know that D can derive A, and the second relationship, A derives BC, that is this one. I'm taking this one, A derives AC. So let's look at this one. Now you notice that there is a transitivity. So D can derive A and A can derive BC. So D can derive A and A can derive BC. So what you can say, using transitivity, you can say D can derive B and C. Now because B can derive BC, you can say, decompose it and say that D can derive A and D can derive BC. Okay. Now you combine them together and say that D can derive A, B, C. So D can derive A, which is obviously given, and using the transitivity, you said D can also derive BC. So D can derive A, D can derive BC. So D can derive ABC. So since D can derive ABC, D can derive any combination of any of these two. And one such combination is A and C. So you can see that D can derive AC. So this is what is given here. D can derive AC. So what we have proved is using this set, we have proved that this is possible. Now let's go to the last one, whether D can derive E. So this is obvious one. So if you take this D can derive AE, let's take this one, D can derive AE. So D can derive A. Using decomposition, you can say that D can derive A, D can derive E. Obviously, D can derive AE. So what we have proved is we have proved that all these relationships can be obtained using this. In the first set, what we have proved is this set can be derived using this. In the second set, second case, what we have proved is this set can be derived using this. So using set 1, you can derive set 2. Using set 2, you can derive set 1. So what does this mean? That means to say that they are equivalent. So we prove that, we conclude that S1 and it should have been S1, S1 and S2. Let's say S2. S1 can derive S2 and S2 can derive S1. So this one. So S1 can derive S2 and S2 can derive S1. We say that both the functional dependencies are equivalent. That is our conclusion. Thank you for your interest. We will meet again in the other exercise.